Hey, what's going on? Welcome to another episode of AngularAir. I'm your host, Justin, and on today's episode, we are going to be talking about bridging the gap between designers and developers. Should be pretty exciting. I always get excited about the design space and the visual space and everything that goes along with that. So really looking forward to it. Let's say hi to our panelists, and then we'll meet our guest, and then we'll get into our content. Joining us today, we've got Bonnie. Bonnie, what's going on?
Oh, no, a whole lot of nada. It's Friday. I love Fridays. I'm actually very excited about this episode because we have somebody who we've seen before and you all know, and then somebody else who you don't know that I've been trying to get on the show for like ever. And so it's going to be a good show.
For sure, for sure. And speaking of those guests, we've got Jeff with us. Jeff's joining us for that first time, right? How's it going?
Yeah, yeah, it's good. Thank you. I had some internet problems just before we launched, basically, but let's hope everything goes smoothly from there.
We believe in you. Are you presenting or is your co-guest presenting?
No, we're both presenting today.
And
So
Bonnie,
I, I
who's that co-guest, Bonnie?
This is Wassim. So I knew Wassim, and I liked Wassim a lot. And then when I moved to Utrecht, I was living in Utrecht when I first moved to the Netherlands. I said something about Utrecht, and Jeffrey said, "Welcome to Utrecht." And I was like, "Are you in Utrecht?" I didn't know anybody, so I told him he had to have lunch with me. And then we became friends. And I was trying to get him to come on AngularAir because he's a cool guy, and I was like, "Come and teach us some cool stuff." And he was like, "Well, I will one of these days, but I'm busy." And then I invited Wassim to come and teach us about XLayers, and he said, "I'm going to bring Jeffrey with me." And I was like, "Yes! Okay, finally we got him on the show." So, thank you, Wassim. You did it. I couldn't do it, but you did it.
I
Well, we
had
got both of them. All right, if you want to tell our viewers a bit about yourself, what you got going on, that sort of thing.
yeah. You wanna?
Yeah, we could also do it in the slides. We got a little bit in the slides
Oh
about
yeah,
ourselves. So
yeah, for sure. You want to start
I
with that?
I hope
yeah.
there's recent baby pictures, at least just a little bit, Wassim, because
Oh, we
you
forgot.
had time off. I know there's pictures,
A lot.
or at least if they're not in the slides, maybe you could pull one up while Jeffrey's talking and give it to us at the end for pics, because we need to see the latest.
There you go. There
I
you
got one
go.
for you.
Thank you.
All right, who's got the slides? Who am I bringing up?
I'm starting.
Okay,
And
you
you're going
ready?
to tell
You
us,
here?
like, what is this X layers thing, right? What does it do? What is
Yeah,
it for?
yeah. We will give you a complete view of the XLayer project and also some of the internals that we use to do our magic, basically. Okay, can you all can see my screen? It's all good.
Yes.
Okay. So XLayers, before we start, let me at least introduce myself. I'm a senior developer at Stipley. That's a digital e-signature company based in the Netherlands. Of course, I'm the one of the two core members of XLayers. I build a how do you say it builder for AWS to deploy your Angular app to the S3 buckets that are there. I'm one of the organizers of the Dutch Angular group, and when I have some spare time, I also do some contributions to the Angular CLI. And if you look at my socials, they're all there. So sometimes I blog, but it's not that occasionally, but go check it out, basically.
This is a very professional looking slide. No, the last one. And then there's Wassim. Wassim, you crack me up. I love your pictures.
Do you want to just skip over it, or Wassim, or do you introduce yourself? Or
Yeah, tell us, who are you, Wassim? What you been doing?
So, yeah, I'm Wassim. Doesn't have to do anything with the Wasm, which is WebAssembly. So we have the same initials. Yeah, I work at Microsoft as a cloud advocate, specialized in JavaScript. So basically, anything that has JavaScript in it, I'm there. And yeah, I do a lot of open source. I'm basically creating apps and tools for developers to improve their developer experience, and starting with my own, and then I share them um, for free to use. And yeah, and that's all about me.
okay, So then we go back to the history of XLayers, basically. A couple of years ago, when Wassim did another job, I think, he saw like a regular problem basically on different companies, where companies have like an idea, and at the end they want to do like, build a product, you know, and there's a lot of things there in between to go from that specific idea to that product. So what you see at companies at that point is that there are like similar workflows like I'm presenting right now, where they have an idea, they are making like some specifications, maybe on paper or maybe complete scripts around it or whatever. And from that point, well, I hope they do some wireframing for the project, and at the end do some prototyping. And when the prototyping is good, you always see that there is like a visual design and code phase where they iterate over, and that takes, well, some time. And at the end, of course, they ship the product. And today we will be generally focusing on the visual design part and code, because that's where XLayers is doing his magic. So looking at these design flows, we believe that they are a little bit broken. And that's basically because a lot of these designs, implementing these designs can be a bit tedious. You all know that all these things, they need to be built with HTML, CSS, and it's like repetitive tasks. So sometimes maybe even developers got bored maybe when doing these things. So these designs, they can also have a effect that they break the code, because designers occasionally start designing, having cool ideas, and for some reason they say, okay, let's redo it and start over with it. But on the developer side, then it will break sometimes their code, and then it need to do like rework, and that's a hard thing for a developer, right? You spend a lot of hours on it, and then you well, for some reason we just need to change it again, and that's not the fun part in this. Another thing with these iterations is that all these iterations cost a lot of money. When you start over again after the design change for some reason, yeah, you need to pay the people that are working there. So the company is spending a lot of money around these iterations, going from designs to code. So at some point in time, and I'm not sure exactly when the point was, but Wassim had like an idea. So how can we fix this problem that everybody's got? And as engineers, we think, let's automate stuff, and we all know that basically we can make something that generates codes for us from a design that should be doable. But if you look at things like model-driven architect and how we could do that, it could be like hard to do these things, and they're well, a lot of work basically. If you look at the past, also you get a lot of tools that already did this, like Adobe Dreamweaver. It was cool, right? You could just drag and drop stuff in there, and you got like HTML and CSS out of it, and it was pretty decent actually when you exported it and used it in your application. But you see, there another problem is that, for example, if we want to adapt it in Angular, you need to do some extra things around it because it didn't have the framework characteristics, and that's what we're all looking for, right? To get it to our specific framework that we use these days. So as I already explained, many great tools have done this, and a couple are still doing this also these days. But all of them are not free. Of course, there are free plans, or maybe even a complete free thing. But if you want to share with your colleagues or within your team, yeah, you need to pay for the license to share it with your colleagues. And all of these projects, of course, because it are companies, well, they are all on a closed source basically. And for me personally, it's also a problem when you have like another supportive cross-platform. For example, Sketch, we use it with XLayers, and it's only on OS X. So when I'm working on my Windows machine, that's my company's machine, I cannot just install a Sketch and see what maybe Wassim did, for example. So I need to do it in another way or figure something out for this problem. And it's good, by the way, that these companies have specific needs. So don't get me wrong there, because that's a company and that's a product of a company. But it can be a hard time as I want to change something in my application. Another thing we see in that space is that if you, for example, take Sketch, you can use other tools to share it with your colleagues. But also here you see that you still need to pay something for the integration or the license at least to share it within your company. And as I already basically said, we still have this problem that we still don't get it in our framework as we would like to have it. So, and here comes the cool part, basically, where we, at some point, we introduced XLayers. So XLayers is like a web application where we basically bridge the gap between the designers and the developers. And it's a pretty easy workflow, and we'll go a bit about it later, to, well, adapt basically the designer's stuff to the developer part. So back to the workflow, where are we basically with XLayers? So XLayers is in the center of the visual design and the code. So the input is the visual design and the output is always code. And basically we do the hard work. We help developers to get to their code basically. So if we would put XLayers in a sentence, basically it's an online code generator service that everybody can use. It's not a designer tool, so we only interpret basically a designer file. So you can show them, you can talk with your colleagues around them and that kind of stuff, but you cannot change it basically. Of course, you can change the code, but not the designer file. As we already talking a little about Sketch actually, and the asterisk that's there basically want to have some other UI design tools basically in our solution, but we are going virtually to any code. It doesn't matter actually at this point in time what we want. We can just generate it. We know how basically. A big advantage is that we're basically fully open source. We're out there. You can talk to us. If we have a meeting, you can join us if you want. If you have a cool idea, or you see a ticket like you want to contribute with us, we're more than happy to help you and assist you with all the problems you're facing with contribution also. So go check it out basically on our GitHub repository to see where we are. So this is for me personally a cool part because XLayers is community driven. When I started with the project, I think it was 1.5, maybe even 2 years ago. I was like shy in the open source world. I never did a bigger project. And well, when I saw the project, it was from Wassim, for example. I said, well, this guy, he's doing a lot of cool stuff, you know. But the introduction and the way we got it working was pretty awesome. And well, here I am at the end as one of the 2 core members. So that's pretty cool. So as we already mentioned, basically we got some contributors and also some backers. So I hope I pronounced it correctly because it's a German company, Centrigrade. They're basically supporting us with the logo. So they did the logo design for us. We got some backers on Open Collective that help us supporting this project. And we have some brilliant contributors there that are assisting us with all kinds of stuff, from simple documentation changes to big refactors in our code generators. So as already mentioned, basically we are going virtually anywhere. So at this moment we got like HTML, CSS, JavaScript, TypeScript. Justin, do you know what the star thing is there?
It almost looks like ICQ from back in the day. I don't know what that is.
It's the original logo for SVG.
All right.
So we also needed to look it up what it was, but also like XML interpretation, that's something we already do. And all these kinds of frameworks we support as of this moment right now. And maybe if you look closely, it's pretty cool because you see a lot of web parts there. But we also support like Xamarin, and Xamarin is like a mobile .NET development platform. So when I say virtually anywhere, we can go basically anywhere. And if you want to do something else, for example, we are on our hot list is still Svelte, for example. We're more than happy to add that to our list because we want to be as how do you say it, big or yeah, let's call it big, basically, with all our frameworks. So to give a little bit around our how we build it, basically. So how did we do it? With XLayers, we try to do the latest version of Angular. And if there are like newer versions, for example, 11 is coming out in a couple of months, I think, we will update it. And if we see issues, we also report them basically to the Angular team so that they can assist us or we can help them. If you look at the XLayer application, on the top bar and the left bar, basically they're all Angular components. And the drag and drop behavior that's in there, because you can just easily drag and drop one of your sketch files in. It's based on the CDK. Our setup is the unit tester basically with Jest and Cypress for our end-to-end testing. And the cool part here is that we also do like version checks from the sketch design files, because they are upgrading with a lot of different versions. And with Cypress, we just switch versions for a couple of versions, and we know for sure that basically these versions are still supported by us. So at one point we needed some state management. We've chosen at that point for NGXS. I think it started basically as an experiment, and we're really happy we adopted it. Recently we made a change to a, well, is it basic Angular workspace, I think you would call it, to a Annex workspace with the cloud caching thing. And the reason for that is that we got a lot of like libraries in there for the code generation, and we saw like big amounts of time in our pipelines to generate all these code and adopt it in several other parts that we have. So Annex is there to assist us basically with an easygoing workplace, basically workspace, and the cloud caching is like an extra thing that we get from that point. If you look at XLayers, we are xlayers.app or xlayers.dev, or I think we even got the XLayers design still there, if I'm correct. It's all hosted on Firebase, and when I think just before Azure, or at the moment that Azure came with the static web apps, we even adopted that for our next version. So our staging part from XLayers, that's next.xlayers.dev, it's on Azure static web apps. So a little bit around our ecosystem, because we're talking now at the XLayers online web app, and that's what the online viewer and the code generation. But we have some more. We've not, well, promoting it that big, but we also got like an XLayers live viewer where you can just add a web component to your app, reference a sketch file, and it will just generate it for you on the fly in your app, basically. So you will just get the HTML, CSS there, and you will get the 3D thing if you want, even the 3D animations that we got in. You can even just have it on in your own app without adopting the complete library or getting it out of the source code or something like that. We just give it to you, basically. And we did like experimenting with VS Code extensions. So we made an extension where you can just go within your VS Code from your project, right-click on the sketch file, and generate the code just next to the sketch file. So that's pretty easy for a developer when you're just getting designers in your project. They update the sketch file, and you can just right-click it, generate it again, and you got your new version basically there. We're still waiting for some releases there because we want to extract some logic from the XLayers online view and code generator, basically to publish them to NPM or something like that to adapt it in there. But maybe we'll get back to you with this thing in another show.
Is there a quick question on that?
Yeah, sure. Go ahead.
Thoughts or exploration in integrating with something like Storybook?
We not discussed it, but we could look at it. Why not?
Nice. It's open source, so maybe we can do it. Sure,
yeah, well, we're more than happy to help with us. And how do you see it then? Is it like you just have a sketch file somewhere and Storybook in your project, and it will just generate it then for you, or do you see it a little bit like that?
Yeah, I mean, I'm just kind of like initially thinking like the fact that you use Storybook for, component driven design and isolation and showing those, your inventory of what you have and things like that. And I think that it fits into the, design development world. So there's probably some fit there where there could be a benefit of XLayers being a part of that process, right?
Yeah, so that you get like the component and the sketch file all like separated or next to each other, for example, where you can just see the design and on the other side, the component that you just built within Storybook.
Yeah. Yeah. And then maybe
Cool.
have it. Yeah. Tie in. That'd be cool.
Cool idea.
Jeffrey, Fergus wants to see it.
Yeah, we're going to.
Are you going to show it? Can you show it to us? Do you have time?
Yeah, sure. Yeah,
I want to see it. I want to. I mean, I was just going to leave him there, but I want to see it.
No, we can go over it. I think we're a couple of slides before Wassim, but I can then switch over just before that, and then we can just demo it quickly.
Well, as long as we know you're going to show, because we want to see it, we'll be patient. Just wait, Fergus. He's getting there.
Yeah, maybe it's good that I just show it right after my spot if we switch to Wassim, so that we have a good idea before we dive in the internals, like the compiler part and that kind of stuff. I think that's a good thing.
We want to see what it looks like.
Yeah, sure.
It sounds cool, but does it really work, Jeffrey? Like, how can it just generate all that code like that? I mean,
yeah. Well, let's wait and see.
Fergus and I are skeptical.
Okay, so long-term goals. One of the things we got on our backlog basically is shareable sessions where somebody can just upload their sketch file and get a link so that you can just share it with your teammates or your friends. We have the idea to do a code generation as a service thing where you can just have an API and post your sketch file there and get code or maybe a zip or something like that. As I mentioned earlier in the presentation, we want to have some extra UI design tools adapted. Of course, more frameworks because there are new ones maybe every now and then. And the hardest part is maybe the semantic code generation. So what you see at this moment is that we can, of course, get it to work with HTML, CSS, that kind of stuff. But we can define like if it is a button, for example, is this specific part, is that a button, yes or no? That's not like the information we got at this point. We have done some experiments on building something with this, but we're not yet that far with it. But we will find a way to get this working correctly. Okay, before we dive in then, let's switch. I think I can just switch over to this. Can you still see it? Yeah, you can still see it. Okay, so this is the basically the landing page, if you want to call it. Can you all see it good? I can see it from my, okay.
Yep.
Good.
Yeah, maybe can you zoom it? I don't know, maybe make it a little bit bigger.
Something like that?
Yeah. Yeah, maybe one more. How about one more?
Let's see what it does.
Enhance. Yeah,
okay, good. So we got two options basically when you go to the landing page to the second page. That is like drag and drop your sketch file in, or like select one of our demo things. And let's see. So I just pressed one of the things there, and basically we got now like a card image where you can toggle a bit like 3D stuff or do some other generation there. You can just zoom in with it or look at the layers that are there basically on the left side. On the right side, you can see some extra properties, or if there are any let's say metadata stuff there, or positioning or sizing, you can all see that. And on the right, basically you have like a code generation button, and when you click that, you basically will go to the generated part. So what do we generate? Basically, we start with an Angular thing. We can go to Angular elements, Vue, React, Web Components, Stencil, and Lit, as I mentioned. This is the README that is telling you how you could adapt it, basically. So how you could adapt this component. We got like a routing module here, a normal Angular module, component page, HTML page, sorry. The CSS also, the TypeScript is in there. And we do some small test file there. What you can do is then, sorry?
I was just going to ask, how do you handle images? if there's images from that you need, like a button background or something like that.
Yeah, I think we add the image as a how do you say it, as a asset there. Yeah, oh, base 64. Yeah, that's the thing. Yeah. So you can download it as a zip. You can go to StackBlitz if you want, or change one of the others. Basically, go to Vue, for example, in this case. Okay. Was this demo enough for Bunny, or? Okay, good. Then
Thank you very much. I just wanted to make sure it actually works.
Yeah, it works.
It just sounded, so cool, but I want to see it.
Okay, let me stop sharing my screen. Now we're going to switch over.
All right, let's switch to my slides, Justin. Thank you. Bonnie, this is for you.
Oh, look at her. She's getting so big. Thank you, Wassim.
All right.
I appreciate that.
So now I'm going to jump into the internals of XLayers and basically give you a sneak peek of about how we built all this stuff. And yeah, but before that, we need to just get some compiler design 101, like really, really quick. Just to introduce some of the concepts that I'm going to introduce next that are related to XLayers. So first of all, what's a compiler? Basically, a compiler it's a tool that tries to converts a program written in one language into another language or a binary. And there are two types of compilers. There are like cross compilers. So that's actually what we usually call compiler, which basically takes a source code and converts it into a binary, like GCC or Java or any other cross-platform compiler. And then there is also a transpiler like Babel or TypeScript, which takes a source code and converts it to another source code. A compiler pipeline is composed of two sections, like the front end phase and the back end phase. And inside the front end phase, there are like a sequence of analysis, which gives us a intermediate code generation, or like a model that we are gonna work on and get our code generated at the end. So let's start with the lexical analysis. The lexical analysis is the first step into of the compilation pipeline. So basically, your lexical analyzer would take your source code, and then scan it character by character, like one character at a time, in order to find what we call tokens. So basically, it would go one letter at a time and then see, okay, this let is a let keyword, and would ignore all the spaces, tabs, and comments, and then it found like an X here, so it would categorize it as an identifier, and then it would find a special equals token, then a numerical literal plus token maybe, and then another numerical literal, and maybe a semicolon token, which indicates the end of an instruction. So basically, starting from your source code, it would build this concrete syntax tree or CST with all the tokens as the leaves, and then all the identified tokens, I would say, as a nodes. And you might wonder, what's a valid token? How does the scanner knows that this is a let keyword, this is an equal sign, and so on and so forth? So it basically uses what we call the grammar. And in our use case today for this talk, we're going to focus on regular grammars. There are actually 4 types of grammars, but the one that we are interested in today is regular grammars. Basically, a regular grammar or a formal grammar, it's a formal set of mathematical rules that defines what is the language. And these rules were actually defined by Noam Chomsky as this kind of equation that you have, like G equals a set of um, non-terminal symbols, terminal symbols, a production rules that basically describes how we go from one rule to another in order to generate our language, and then the initial state. I have an example for you here. And by the way, I didn't mention it, but it's type 3. The regular grammar is type 3. So the non-terminal symbols here in my example would be, maybe just as an example, A, B, D, F, J. Our terminals would be let semicolon x equal plus and all the numerical values. And then our initial state would be starting with A and B. And the production rules are the following. I'm not going to detail them, but basically you start from S and then you derive it into A space capital B, and then you take capital B and capital B and then derive them to their derivations. For instance, this is a language that is generated by this grammar. So anything that starts with let space x space equal and so on and so forth. And this is an invalid language that is not generated by this grammar, for instance. Next, we have the syntax analysis, or this is what we call actually parsing. When we talk about parsers, we usually refer to syntax analysis. And basically, a parser is the second phase after the lexical analysis. And the parser would take what we call a context-free grammar and then generate an AST or abstract syntax tree. A context-free grammar, which is type 2, this time it's kind of similar to the type tree, but it's like more simplified, if I may say. But it's the same recursive rule that are used to generate a pattern of strings, also called a language. And what I mean by the language, the language could be like the programming language, like JavaScript, or it could be like English or French or Spanish or any kind of language. So, in your opinion, is this a valid JavaScript construction? Let's say yes. So this is actually really valid. And why is it valid? Because of the JavaScript grammar. You can find the link at the bottom of the slides. So this is a section from the JavaScript grammar that describes how we construct an array literal. And basically, these are all valid JavaScript arrays. And the last one, as you may see, these are basically a lot of undefined values inside. And also the parser is where the error handling is done. So for example, this is a valid JavaScript array. This is not a valid JavaScript array. And we all know it because we all got this kind of unexpected token because here we are not, the parser doesn't understand actually what is this construction, because it's expecting like a close-in array literal and not an object. Now the lexical plus this syntax analysis gives us this simple diagram. We start with a lexer that takes a regular grammar or a formal grammar. Then it generates a CST, a concrete syntax tree, which then is used by the parser. And then we have the AST, syntax, the abstract syntax tree. In between the AST and the parser, we have this semantic analysis. And I'm just going to quote Wikipedia here. But basically, this is where the extra stuff is happening, like type checking, or where the parser would check if a variable is defined before it's used, or this kind of stuff. Then we have the abstract syntax tree, or basically very simplified version of the parse tree that we had earlier, the CST. And basically, we can, as a developer, we can put anything inside an AST, anything that we would need to use for our code generation part. So here I give you an example of the TypeScript AST, where you could find the position of the character, like the line and the column, and the kind of the token that was identified, like for instance, a variable statement, or let's say just like a literal or a token, like let keyword, for instance. So that was the first phase, the front end phase, where the compiler takes your source code and then generates an AST. Then comes in the second phase, which is the backend phase. And basically, this is where all the optimizations and the code generations happen. When it comes to intermediate code optimizations, I just listed there a bunch of optimizations that are done because this is really related to what you are doing. In our case, we don't need all these optimizations to be done for XLayer. But for instance, this is where the dead code eliminations is done, or the enlightening expansion is done as well. And I highly recommend you checking out the static single assignment, the SSA. This is I discovered this quite recently, and basically this is if you take the Go compiler in version 1.7, the team rewrote the whole compiler using this SSA technique, so then they could generate highly optimized code for basically any architecture or any CPU, like for ARM, for Intel, for a lot of different kind of architectures. I'm gonna just explain two examples. One of them is constant folding, because this is a lot. This is done a lot in JavaScript, where basically when the compiler finds like a static expression like 1 plus 2, it would just fold it as a single expression. Like, okay, 1 plus 2 is 3, so let's just put 3 as a value there, and I'll simplify our tree. The other optimization is variable renaming, or as we know it, name mangling in JavaScript, where basically the compiler would rename all the variables with a unique identifier, so it can optimize them during the code generation. And this is also where some compilers like Java compiler would also put some semantic meaning or like semantic information into the variable names. Maybe you've noticed this sometimes, where variables like during the when you have errors in your Java stack, you will see like names with numbers and then like dollar signs and whatever. This is actually where the compiler puts some reference addresses, so it could use it during the code generation. But this is like really specific to Java, for instance. And then the code generation is really basically just visiting your AST and then generated code. So here in our example, we are transpiling, let's say, an ES6 into ES5 code, replacing let with var. So this is basically like really like high-level pipeline of a typical compiler with front-end phase and back-end phase. So now, for what this all means for XLayers. So let's take a moment here and think about our goal for XLayer. So our goal for XLayer was to take a sketch file and then output some code, like let's say HTML code. So in between, we had to create some sort of compiler. So XLayer is our compiler, basically. And it all started by me 2 years ago trying to reverse engineer a sketch file, because my question was, what if I could generate code from a sketch file? And so I didn't know anything about a sketch file. I just knew it was a binary format. So, and by accident, one night, one evening, I discovered that was actually a zip file, like an archive. If you're using macOS, you have the quick look when you press spacebar. So this is how I discovered this, actually. Like, I pressed spacebar and like I had the uncompressed version of a sketch file with all the files inside. And I say, let's use nzip. So nzip it, and then we found this information inside these files inside the zip file, sketch file. And yeah, basically lots of PNGs and also some metadata. But this file caught my attention, the data. And inspecting this data with an Hexa editor, yeah, lots of binary. And one thing that I noticed, this BEP list string. And if you are macOS user, you know what's a plist file format. It's a property list that's used by macOS to put some information about your computer, like drivers or recent open files or whatever. And the B in front of it is a binary format. Okay. I was lucky enough to find out that Apple had open sourced the specifications to this binary format. So the table you have on your right is basically our grammar. It's a weird grammar, but it's our grammar. So we will use this grammar actually to try to parse the binary information you have on the left. And the specification says, okay, the first magic number of magic bytes define the file format, and basically all the binary formats have this kind of magic number. This like PNG or TIFF format or whatever. They would have this initial bytes in them, then followed by some version number, and then the last 32 bytes define some extra information on how you basically navigate inside your binary information, like where all the I don't know, maybe the data, the dictionary data is located in the memory. So you would have all that information in the last section. This is all done by the like specified by Apple specs. And then all the rest is your data. Okay, so easy. Let's write a BPList compiler. Took me a couple of evenings to do this, and then once I finished, I discovered actually that this binary data is actually JSON. Like when you convert it, like when you generate code from the binary, you get some JSON. But sometimes you get this kind of information, like with a JSON with, I guess you know what is this? A base 64 string. Easy. So we have this in JavaScript. Let's just decode it, and then decoding the base, like the embedded base 64 string into regular string, we get a binary plist again. Are you kidding me? So these guys were like embedding binary encoded in base 64 inside an encoded inception, like maybe I was never mind. Okay, so we had this pipeline working where we could visit all the nodes and then generate the final output. That
Sounds like a job for recursion.
yeah, that's a lot of recursions there. And then one day I saw this. So starting from version 43, the sketch team, the sketch software would have a different file format. All right, let's try it out and zip in the sketch file again. And this time, all right, that's exactly a new kind of different format. But this time there is no data. You could only see a lot of JSON format, the JSON files. And then, JSON, okay, it contains the same information as the information we had to decode earlier. So basically, there is no more need for all this compilation or like decoding and parsing pipeline. Never mind. I was happy to do it for free. I learned.
Well, you got to do that. You got to do that PR with a bunch of removal of code, right?
Not
Absolutely.
really, because we had to support legacy versions of XLayer of
Oh,
yeah.
You're right.
But we're discussing this. Maybe we'll remove it soon. So that was the parsing all the binary information or extracting JSON information from the sketch files. Now comes in the styling information. And as you remember, we want to convert sketch design into web language like CSS and HTML. And for the styling, we had like basically to write a CSS parser with a CSS optimizer. And writing the CSS parser was kind of straightforward, just like had to visit all the nodes in like depth first search. Basically, that was the most optimized way to do it because it has some advantages like lower memory usage because we only visit one branch at a time, high performance because the grammar was simpler, as you remember, like the plist specifications by Apple, and easy to implement because, as you say, Justin, it's all recursion. And then from the basic AST information, we then have CSS information like CSS properties and declarations. And we also generate some random CSS names to make stuff easier. But then we had some problems because as a designer, like you duplicate your layers, you use the same style many times. And this ends up actually in our AST file, I mean AST model. So we had lots of silent duplications everywhere. And this is where Jeff came in and wrote actually an optimizer for it to deduplicate all this information and then basically have only one simpler declaration and then for all the common nodes that are using that particular declaration. And then basically that's it. That's our pipeline. Like we start with the JSON as our AST, like starting from version 43 and above, and then we enhance it with all the optimization that we do, and then we pass everything to our web code generators where we generate CSS, HVG, and also HTML and sometimes JavaScript if we need. And to answer your question, actually, Justin, earlier, we also found out that sometimes inside the sketch file, we have some PDFs and images embedded as base64 content. So then we had to decode them and output them as base64 also into the final generated code. And albeit this is not very optimized, but this is how we can do it. We've discussed many options there, like generated a blob, but then blob is only like living while you have your tab open. Once you close your tab, you kill the reference. So for now, base64 was the most straightforward operation to do. And that's basically where like we started with Angular because we're Angular developers. So we generated code for Angular first and then Angular elements, and then came in all the other languages and formats. And we're also open, as Jeff mentioned, we're open to different languages. We're trying to be diverse, as much diverse as possible. So we have Flutter in the pipeline. We have Xamarin working. That was actually a contribution by some external folks. And yeah, if you're thinking about any other, we could imagine, for instance, like we could imagine having an Android app generated because it's all Java and XML, or an iOS app, or whatever. And then Jeff has some exclusive announcement for you.
Yeah, well, I think 2 weeks ago we had this discussion like, okay, what are we going to do at AngularAir, and what are we?
Yeah.
Oh boy.
Okay.
So have you ever felt the urge that you was working in a project, but you like copied over like a bash file to version stamp your application? That you saw like, okay, this is this version 1.1 or 0 or something like that. I think many of us just copied over like scripts that they use to stamp a specific version in your library. Basically, we did it for all our projects that we do, but we also had some problems because of that, because I'm still working on my Windows machine and Wassim is working on his OS X machine. So we thought, well, let's get an exclusive announcement out here right on the spot. So we built a builder for you, the XLayer's version stamp builder that you can just use in your Angular application by using ng-add XLayer's version stamp. And you can just run one command and it will stamp basically your library with a specific version or a git hash basically on your branch. So this easier for you in the pipeline, basically. So this sorry.
And then what can we do with that once we have that version? Like, do we display? We put it in the code so that we can see it on when we inspect source online.
Basically, if you can see my screen here, I have this build with a number here, with a version number. That's basically what the builder is doing. It would stamp you this version, because this is a lot of customers are like requiring this or like asking for this feature, and we all end up using, as Jeff mentioned, writing like script shells to do this and to go over your artifacts and then find the pattern and then replace with the version you want. And so Jeff made it easier for you, just one command and you're done. It takes all the hard work for you.
And so we can do this in our own projects, like separate from XLayer.
Yeah, it's
right?
completely separate. It's completely separate.
So when I've got the app that I'm deploying to several CI environments, and I have a QA team that's looking at those, and they're saying they don't see the latest changes, I could use something like this to identify it with a commit hash to know that like that code that it was actually pushed to that version.
Definitely. And actually, we're also using this on XLayer. So we are using it on XLayer production, but also the staging, and also for every PR that's created. That's super handy. I was duplicating all the scripts for all the apps I built.
We had a couple of quick questions and we're running out of time.
That was the end.
Wassim. Well, there was one question. Rares wanted to know if there's any other programs that this works with other than Sketch, or do you have any plans for that in the roadmap?
Yeah. So basically, at the moment, it's still Sketch, but we're thinking like Adobe XD or any other things that relates to designer tools.
Yeah,
and that we can interpret a bit.
Yeah. Okay, and
InVision.
Go ahead, Wassim. And what?
InVision. We're also exploring InVision.
Yeah.
The software. Yeah.
And the other question, I think that all of us are where, because our brains were melty a little there on your part, Wassim. That was a lot, and we were our brains were a little fried, but we are fascinated with those lights behind you.
Oh,
it's so cool. What is going on? Because it makes noise when you make noise. It makes noise when I make noise. This is so cool. How did you do that? Tell us.
Oh, these are the NanoLeaves canvas. You can get them from NanoLeaves, like basically 15 centimeters squares that you put together, and then you have lights where you can play with your mobile phone, or it could also detect sounds and react. And it's also touch, so you can touch them or play.
Let me see.
It's great for kids.
Can you touch it? Like if you just reach back there and touch it, can you reach it?
It's too far from my mic.
But there's something on the wall.
Yeah, it's stuck on the wall. Yeah, definitely.
That's so cool.
Just look for NanoLeaves canvas. They have like different models.
I want to be just like you, Wassim.
I mean, you can. What's stopping you?
Yeah. Rara says you wake up one morning and you drink a coffee and easily reverse engineer sketch files and write a compiler and learn about AST and then voodoo magic on a Sunday morning.
My problem is I never wonder what if. Never start a question with what if. Like, what if I can do this? What if this can be done? What if I can control my standing desk with my voice? And then you go for a month of doing stuff.
That's all you can think about doing, right?
Yeah, that's also if you're curious and you wanna you wanna know, you wanna understand how things are working or are made. Just go do it. I mean, there's a lot of information on the web to help you get started. And if you want to contribute to XLayer and learn all the stuff, please reach out to us. And we're on Discord. There's a link there. We're on Twitter, on GitHub. And as Jeff basically, by the way, mentioned, we also have 3 domain names because we're inclusive. So we are the .app, XLayer.app, XLayer.dev, and XLayer.design. So we're developer friendly and also designers friendly.
That's awesome.
Very cool. Very cool. All right. Well, we're at the top of the hour. It's perfect timing. fit everything in. That was great. All right, should we? Any last bits on? I guess we're good. We're covered, right? We got the links in and everything. So let's do some picks. If anybody has any picks, Bonnie, do you have any picks today?
I have a pick right after this, like literally like right now in 3 minutes, we're doing community office hours over on Angular Nation. I think Wassim doesn't have time because he's got to go, but Jeffrey's going to come with us. So if you guys have any more questions about XLayers or if you just want to hang out, then come and join us right after this on angularnation.net. And if you need to sign up, I'll go as soon as this show's over and I'll approve any pending request to join.
I'll try to be on Angular Nation tomorrow morning.
All right. That's awesome.
Nice.
We'll be happy to see you.
Yeah. Nice. All right, I'll have a pick real quick. I got this new mic arm. Bonnie knows about it because I think she has the same one. It's this blue. I like it. I like the design on it. It's got kind of like this rectangle bar instead of your kind of 2-bar, looks like a femur bone thing. So this one, I like the look of it and stuff better. But it's a little challenging. It goes on tension. And the mic that I had just got, which was an Elgato Wave 3, is like, let me grab it here, is like way too light. So it doesn't hold the bar down. And so now I'm in search of some weights or something to help with the tension. So I put my other mic on here because it has a little more weight. But other than that, I think that this mic arm is pretty cool. So we'll see. But I guess that's my pick. All right, let's ask our guests. Do either of you have any picks you want to share?
Let me mention Tim de Schrijver. He's one of the contributors or the team. I think he's in the team of the NGRX. He does a lot of writing a lot of articles around Angular and some other .NET or other open source related stuff. So go check him out.
I love that guy. We need to have we had him on the show, Justin?
I don't think that we do. I mean, we had a lot of shows, so I can't recall. I guess all of them. But
I'll reach out to him. If he's watching this,
we need him on.
Come on the show. I really like that guy. He's so great. I'll reach out to him and see if we can get him on the show. That's a good pick, Jeffrey.
Yeah. All right. Well, Steve, do you have anything you want to pick?
And I'm going to mention Santosh Yadav. If you don't know this person, please follow him on Twitter or follow his YouTube channel. He's an awesome person. He's very inspiring. And just wanted to give him a shout out, actually.
He's been doing a lot of shows lately.
Yeah.
I think he's going to compete with AngularAir. Maybe we should not talk about him. No, I'm just kidding. He's so cool. And he's had some really good guests on too. So yeah, you should check out his show too. I'm just kidding, Santosh.
Yeah, for all our viewers out there, hey, we're not about the competition thing. Please, if you want to get in the space and share your content, we welcome it. Absolutely. The more content, the better for everybody. So for sure. I love the fact that all of our picks, most of our picks were around, other people. That's awesome. So for sure. Awesome. Well,
that's what
Jeff,
makes the community.
Right. Yep. Sharing and promoting other people, all that stuff. It's great. Hey, Jeff and Wassim, we super appreciate you coming on, sharing your time, sharing your knowledge with us. Thank you very much. And awesome to have you on. And as always, we're more than happy to have you back on anytime you want to come back on. So
thank you.
I have a question for you, Justin. Do you still have the GitHub stickers that I sent you 2 years ago?
I absolutely do. And I still have not stuck it on. So it's a Day of the Dead GitHub AutoCAD. Yeah. And it's my favorite thing. And I haven't stuck it anywhere because I'm so scared to stick it on something and make it permanent. And that thing I put it on has to go away. That's my favorite sticker. So
that's how I feel about this one. I don't know where to put it. I'm waiting for the right moment.
Yeah, I absolutely do. Thank you. All right. That's a wrap. Thanks again. We'll catch everybody next time. See ya.